When it comes to finding missing sides in right triangles, we have to use what's called the Pythagorean Theorem. Now, most of us have heard of that. It's a squared plus b squared equals c squared. A squared plus b squared equals c squared. However, one of the most common mistakes that I find that my students make is that they don't know what the a, the b, and the c are, all right? And it's easy to mix those up. So in this video, we're gonna do it nice and quick with 3 quick problems. Maybe find the one that looks like the one you're struggling with and go to that part of the video. Let's just go through these. And when we think about the a squared, the b squared, the c squared, really the a, the b, and the c are sides, and we have to put that in the right order. The c is always going to be what's called the hypotenuse. All right, that's going to be the side across from my right angle. The two sides that touch the right angle are called the legs. Okay, so in this right triangle, my two legs are 12 and 5, and the hypotenuse is x. That's what I'm trying to find. So since the x is the hypotenuse, and that always has to be the c value, I'm going to say the equation that I can set up is going to be 5 squared, that's like my a squared, plus the b squared is going to be 12 squared, the two legs are the a and the b, and this is going to equal the part I don't know, which I have to say is x squared. Okay, if I do the math here, 5 squared is 25. 12 squared is 144, and that is still equal to x squared because I don't know what that is. 25 plus 144 is 169, and this turns out to be a perfect square number, which means in order to solve for x, if I take the square root of both sides, on the right side where the x is, the square root and the square are going to cancel. And on the left side, the square root of 169 happens to be plus or minus 13. Now, because this is geometry and we don't have negative values, we're only going to use the positive one. So I'm going to say this is 13 that equals x. And I can put this back in, and that satisfies my problem. One thing before I move on to the next one, and that is that our hypotenuse will always, no matter what the triangle looks like, it will always be the longest side, okay? Let's try number 2. Number 2, this time I have what the hypotenuse is, and that is 10, which means when I replace my a, b, and c, I can replace the c with 10 in this one. So the only other one I have is that's a leg is going to be the 6. So instead of a squared plus b squared equals c squared, one of those legs is going to be the a. I'm going to say this is 6 squared. And then the b is the other leg that I don't know. So in this case, this is the x. All right, x squared. And then the part across from my right angle, the hypotenuse, that's my c, and this is going to be 10 squared in this one. All right, with a little bit of math, 6 squared is 36, x squared I still don't know, 10 squared of course is 100, and now this time my x is what I'm trying to get by itself, so I need to move the 36 to the other side using inverse operations. It was positive, so I'm going to subtract 36, and this gives me x squared equals 64. And again, just like the last one, when I had the x squared equals 169, to undo that square, I'm going to take the square root of both sides. The square and the square root cancel, leave me with just x, and the square root of 64 is 8. Now you're probably asking, well, what if it doesn't turn out to be nice? What if it's not a perfect square? What if this was 67 or something? It'd be like 8.3 or whatever that would be, okay? Then you can use the calculator to maybe help you out a little bit, but for the ones that I'm doing here, it does happen to work. Okay, the last one, maybe you have something kind of interesting like a square root in your problem. If you have this, again, I have to put it in the right order first, A, B, and C. Which one's going to be the C? Is it going to be the 4 square roots of 2, or, I need to put my x in here, or is it going to be the x over there? So which one do you think is the C value? Yeah, hopefully you got it. It's going to be 4 square roots of 2, the part across from my right angle. So that means the other ones, the 4 and the x, I can say 4 squared, that's like my a squared, plus x squared equals 4 square roots of 2 squared. All right, you can square that, that's fine. 4 square roots of 2. You might want to put in parentheses so you can square all of it, right? But you can square that, that's fine. Let's do the math. 4 squared is 16. I still don't know what x squared is, so I'm going to leave it as x squared. And then the way you do this, you almost want to think of it as kind of like 2 parts that are being squared. 4 squared is 16. In fact, I'll do this off to the side here. And this is being multiplied, so we can still multiply. And do you remember what happened earlier when we had a square root that was squared? If I go back to this part, this was squared, and we took the square root of it. They canceled. This is also going to cancel. So it's really like saying 16 times 2. The 4 squared is 16. The square root of 2 squared is 2 because those parts would cancel. All right, so this is 16 times 2 is 32. Now with a little bit of math, I can subtract 16 on both sides and get x squared equals 32 minus 16 is 16. And just like before, take the square root of both sides so those cancel. And the square root of 16 is 4. So here, x is 4. The other leg is 4, which happens to mean that this is an isosceles right triangle. So hopefully you found this interesting and helpful when it came to the Pythagorean theorem. And until next time, keep doing your math homework fast and accurately.